Go ahead, we are live.
Good morning, afternoon, and evening to all our attendees who have joined us from all around the world for Hope 2020. We have 8 more days of Hope 2020 with some really cool talks, workshops, and villages to learn from. So please stay tuned and enjoy our amazing sessions coming up for the rest of the week. Today, we all are encouraged to use end-to-end encrypted communication. But how do we validate trust? Our first talk for the day is titled A Death Blow to the Web of Trust by aestetix. He would talk about how PGP protocol works and explain some flaring issues with the web of trust in PGP is broken. Aestetix also likes to talk Lithuania, but we don't talk about it. Aestetix, please start your session.
Hi everyone, I'm aestetix, and thanks for watching this talk. Before I start, I just wanted to give a quick shout out to the Hope Conference and everyone who's involved, be it an organizer, be it volunteers, and especially the attendees, the people who paid for tickets, because really I think everyone is facing a monumental challenge with this disease, and trying to take all this stuff online has been a huge challenge for all of us, but even more importantly, the people who have been directly affected by the disease, just to know that my thoughts are with you. That said, this talk is called A Death Blow to the Web of Trust, and for those who are not familiar with PGP or the Web of Trust, I'll get into that in a moment. And just for reference for people who might not be aware, the image is taken from the Nintendo game Mike Tyson's Punch-Out!, where you have Little Mac hitting kind of an effigy of the PGP. So the thesis of this talk is that I really like the PGP Pretty Good Privacy, or the GNU PG, the open source GPG protocol. However, I want the public key servers to die. So let's start with the short primer on what PGP and GPG, which I will use those terms interchangeably. Let's start with the short primer on what those are. So we have two kinds of cryptography, symmetric and asymmetric. So let's start with the scenario that Alice and Bob. Alice wants to send a message to Bob, but Tommy Trickster is an evil guy and he wants to intercept this message. So the question is, how does Alice communicate? How do Alice and Bob communicate securely? Well, before 1991, which is the advent of PGP, the steps to defeat Tommy Trickster were, number one, Alice and Bob would meet somewhere secretly and agree on a key. Number two, they would then use this key to both encrypt and decrypt their messages. And number three, if Tommy Trickster learns the key, they're fucked, basically. We call this symmetric cryptography because it uses the same key to encrypt and decrypt the message. So next we have, when PGP came out, this concept of public key asymmetric cryptography was actually around for a while before, but PGP is when it became really commercially accessible. So with PGP, we have the steps to defeat Tommy Trickster. Number one, Bob publishes his public key. Number two, Alice finds his public key and uses it to encrypt her message. Number three, Bob receives Alice's message and uses his private key, which only he has, to decrypt it. Tommy Trickster must get Bob's private key to read the message. This is called asymmetric cryptography because it uses one key to encrypt and another key to decrypt. And the idea would be that you have, it splits into two keys, so you would have a public and a private key, and you keep the private key for yourself, and you give the public key out to everyone else. So this brings up two new questions, which is, first, where can Bob publish his key so that Alice can find it? And second, how can Alice be sure that this key is actually his? The general answer that was created by PGP is we create a key server that is full of signed keys. That is, I create a key, and then I upload it to the key server so you can get it. But then the question is, how do you know that key belongs to me? Well, we have this concept called key sign-in, where, let's say Bob wants to publish his key, Alice will then use her key to sign Bob's key, and then Bob's key, signed by Alice's key, goes to the key server. And so if I am searching to find Bob's key, I can see that Alice has signed Bob's key, and I already trust Alice's key. Now I can see that because Alice has signed Bob's key, I can trust Bob's key too. And in general, this seemed like a really good idea at the time, and many key servers were created, and this was effectively called the web of trust, where these key servers all key servers were distributively sharing all the different keys and the key relationships. There is a big problem with this. There is a big problem with this. The problem is that when you publish a key that has these sign-ins, it reveals your trust relationships, and it effectively reveals your social networks to the world. And this can be really problematic sometimes. So I think this is a huge security risk, and so I decided to see how I could stop people from uploading their keys to the key server, or at least not sign their keys. So the first attempt at this I did was a bit of data mining. I did this for Berlinsides in 2015. I downloaded the SKS key servers, which is effectively a public version of a key server system. They have nightly builds nightly dumps you can download. So I downloaded all of them, and I decided to convert the keys into a SQL database, and I wrote some SQL queries that would do analyses on the keys to find out maybe we could identify some patterns in this, and you can see some of the things I did, looking who has Gmail, who has Hotmail, and so on. And an interesting thing out of this, normally you can see who you can do searches to find out if a given key who it is trusted by, and I wanted to flip that on its head, so I had a tool that allowed you to see who the key had trusted. This is no longer online, and this was really the first attempt I did. The problem I ran into with this is I would say 90% of the keys in the key server are crap, or throwaways, or whatever, all the different things about expiring keys. Nobody cares about that. They just throw junk into it. So the next attempt I made was, well, maybe the keys themselves don't matter so much, but the trust relationships do. So I thought, well, one interesting thing about the protocol is that you can sign, like a person, let's say that Alice signs Bob's key, right? Well, what if Bob doesn't actually know Alice? There is no way for Bob to say, no, I don't want Alice to sign my key. And I decided to have some fun with this. In 2016, I wrote a little tool that, as you can see here, using some config and whatnot, it would you could create keys, and in this case Edward Snowden, and it would search through the key servers, and it would automatically sign all the keys that matched whatever the group was. Now, I ran into a problem here because I'm sure many of you are familiar with Buckaroo Banzai, great sci-fi movie. It's from the 80s, one of my favorites. Well, I gave this talk in Germany, and Germans don't know about that, so this whole joke kind of fell flat, and they appreciated the idea, but yeah, it didn't. I wish I had done this in the US instead. The problem I ran into here. Well, first off, nobody cares what keys are in the database. That was the first attempt issue. This problem, it turns out that nobody actually checks to see who signed whatever keys. So that was a huge waste of time. So then I started digging a little deeper, and I thought, well, what if I can play with client-side security? Because it turns out with the protocol there really isn't any. So I did a couple of things. Here's one where I I removed the email address validation from the code that generates keys, and I created a key that is called We Surrender, and the email address is France. That was kind of cute. Then I did another key where I tried to do some cross-site scripting, which sort of worked but not really, and ultimately it was a dead idea. The idea here was I thought if I could do some kind of cross-site scripting, I could do a JavaScript attack inside of it, and then when a key was loaded into, like, was it Fire GPG or tools like that, then it might cause some havoc that way. Unfortunately, this was a dead end. So then I started thinking, well, why does a key have to be a certain length? What is there a simple way that I can create a ridiculously large key? And there is a size limit when you create it with GPG, GPG gen key and so on. So I decided to download the source code, and I found the place in the source code where the maximum length was, which in this case is 1024 characters. and went through the packet length and so on, and I basically just added a whole bunch of zeros to it. And doing this, I was able to run through, and I created a key that was, I think, 1.9 megabytes in size. And this actually ran, and it caused some issues because as you can see here, it caused some issues because I could actually upload this to the key servers with my modified client. But then when you try to download it, you can see here on the left side where it says GPG list package and please for.gpg, it says it's too large. So I can upload it, but this is, in order for this to work, everyone has to have the same specially compiled code, and it was just kind of ridiculous. The other issue I ran into was, if you look at the public key servers, they're all run by independent entities, and so HKP itself, which is the protocol, when you do the GPG send, server send key, when you upload your key to the key server, it effectively does an HTTP post, where it has the host would be the host name of the key server, and then the path would be pks-add, and then the key itself is effectively, when you do GPG export armor and you get that, it basically takes that and it formats into something that's URL friendly, and it appends that as the post data, and that goes and gets uploaded. And so that's the entire protocol behind the key server, at least for the input side. And one of the issues I ran into is the key servers. Well, first off, you can see in this list of the host names, some of them support IPv6, some don't. Some support HKPS, which is the SSL, the secure version of it, but most of them don't. Some of them are running Apache, some of them are running Nginx, and some of them have a timeout of like 30 seconds, and some of them don't. And in order to get this working, I actually had to go through all these different key servers and keep uploading it and get in timeouts until I would find one or two key servers that didn't have a timeout set and would actually allow me to upload the keys. So that was a lot of work, and I found out a lot about the key servers in the process, but yeah. So this brought me to a new question, which was, how can we upload large bloated files to the key server while using all standard tools? Because my custom compiled GPG works for me, but that doesn't work for anyone else. So if you step back and think about how a computer works, you have this idea of the file allocation table, which is how a file is stored on a disk. So we have a file, we break it into chunks, or clusters in this case, and or blocks, and you put them onto a drive. And what I realized is that in the same way that a file allocation table, or in the same way that a file can be broken into chunks, we could also take a file and break it into keys. And if you have the keys serving as the individual chunks, then we could actually use this and upload it to the key server. So in general, we would take a large data, like, I don't know, an MP3 or something, break it into component parts, add it into the keys some way, and then upload the key to the key server. So I did this for my fourth attempt, and we called this was for Berlinsides 2017. And this was a lot of fun. And in general, the way that I decided, if you recall earlier where I was playing with the comments, I basically figured out one of the attributes of a GPG key is the ability to add a comment. And normally that's something like where somebody is, why it is they're creating the key. For example, if you look through the key server, you'll find a number of keys that have to do with, this was created at such and such key sign-in party. And what we want to do now is I went through the code, and I found it did some back and forth on this, and I found the maximum size character length that you could take a comment, and then I took that character length and I took the MP3 or whatever else, and I split it into chunks that were exactly that character length, created keys of that length, and then uploaded that. Okay, yeah. So as you can see here, the way that effectively worked was it creates a key, uploads the key to the key server, and then you have a key signature that you can use to refer to the key that's in the key servers. So ultimately, this created this created a makeshift version of a file allocation table, which I called a CAT, a KAT file for key allocation table. So there's some issues with this, there's some good things too. First off, the way keyservers work, the keys themselves are never deleted, they're only revoked. And in fact, if you take a look at the pgpmit.edu FAQ, frequently asked questions page, it says, can you delete my key from the key server? No, we cannot. And they recommend that you simply revoke it, although revoking just basically creates revoking creates a flag in the file of the keys that's similar to sign-in or doing a sub-sign-in of a key. So you revoke it, but the key never goes away. So this is actually good for us, because if we want to store a file safely somewhere and we're worried that a disk might fail or something, then it's the key's never deleted, so we never have to worry about the key going away. And in this, the key servers have actually effectively become a RAID 1 cloned system. And you can see here RAID 1 is where you have disks 0, 1, 2, and 3 that are all effectively duplicates of data, so that if disk 1 goes down, you still have 3 disks that contain all the same data. Well, it turns out that the key servers that comprise the web of trust also turn into a RAID 1 system. So I upload the key and it gets distributed, and every key that I uploaded will get distributed, and so thus my file is pretty resilient. That's nice. And it's also a fun and hilarious way to abuse the public key servers. So there's some bad things. First, you don't control where your data is. It's sort of like uploading something to the cloud. Unless you're running a key server, but then you still wouldn't control where it is if it's on these other key servers. You can't lose your cat file. And this can be annoying because the cat files get really big and they're really bulky, and they themselves become a really large file, and it's a pain in the ass. Next, it's very slow. So let's assume that we have a script that's going through and uploading key one by one. Well, you also have to wait for assuming that the network speed of uploading each key, waiting for the server to verify it and process it, and some of these key servers are really slow, so that's no fun. And ultimately, if you're trying to upload like a couple of megs of keys, that can take a while. If you're trying to upload any more, then forget it. At that point, you're not trying to store data, you're just messing with the cloud, which, I do approve of messing with the key servers, but still. Finally, it's really only security through obscurity, because if you're trying to securely store something this way, in theory, you could take a look at the keys, and the keys that are generated by pgpfs are all going to have similar metadata on them, like the name of the key, and you could, in theory, like group them out and download them and recompile, so it's not super secure. And I just want to set the record straight on something here, because I know this came up a couple of years ago in terms of people screaming that the key servers were, vulnerable to attack. And, they are. But if you notice, I uploaded this to pgpfs, and the last commit I had was in July 5th of 2017, and that was before it became a discussion. Now, there was some subsequent articles. There was somebody else, Yakimok, who the first commit in his repository, or her, not sure, I think his based on the picture, the first commit in Yakimok's repository was in May 28th, 2018. And I haven't actually had a chance to look through the code, but I imagine it does something fairly similar to what my code is doing. Power to him, and great. I like to see this, and there's also a medium.com article about asking the question, are SKS key servers safe? Do we need them? And then I like to, why did I write this? And one of this is another reason to explore this. It is not the reason I am. And finally, Robert Hansen and Dan Gilmore caught wind of this, and they wrote a whole statement about this, and they found that indeed the key servers are under attack. And yeah, but I also hate them. But anyways, I just wanted to set the record straight that what I'm presenting may seem like it's something old hat, but I actually came up with this before these guys did. So now that we've gone through and created did some database stuff, data mine, and that didn't really result in anything, and did the trust relationships that nobody cared about. We have this. The question is, how can I improve this sort of file sharing thing? And the other question, of course, is it more important to be able to upload and retrieve things from the key servers, or is it more important to just create havoc for the key servers? And how do we improve on the general user experience? One, we could store the cat file in a database. That makes things a lot easier. That's what databases are for. Number two, try to pass the workload on to others, because there's a few reasons for that. Number one, it's a pain to have your system running for a week or 2 weeks, constantly uploading these keys. And the other is that if key servers caught wind of what you're doing, then why don't they just block your IP and prevent any upload from you? So that's kind of tricky. So we're a community-oriented conference. We want to use the community to also help upload these things. So finally, we want to give people an incentive to use it. Who's going to upload stuff to the key servers? So I thought about this a lot, and I came up with something new based on these things. We want to make sure that our IP doesn't get blocked. We want to have an easy way for people who, maybe if they're not even technical, can use it, but we want to have a way to distribute this. And we also want to reward people. So I broke down the idea that I had into a few basic steps to give you an idea of the next iteration. So first, we would have a key generator that, on the right there you can see number one, it runs on a ridiculously large file, and it creates a database that is full of keys. And by full, I mean really full. And we'll get to this in a second. Number two, the web browser client requests a key from the web server via some JavaScript, because everyone is using JavaScript these days, so it must be a good way to do it. Number three, the web server fetches the key from the key database, fetches a key, it just picks a key from the database, and then sends it to the client, that is the JavaScript that's on the web browser. Number four, the web browser uploads the key to the key server, the key server on the web trust via some JavaScript, and this is important, from a unique IP address. Number five, the key server sends a response code. Hopefully it's a 200, 200 being a successful request. Number six, the client JavaScript reads the response code and tells the web server it has uploaded the key. And then the web server marks the key as uploaded in the database, and the web server then rewards the web browser with a cat photo from the cat photo database, because everyone likes cat photos. So, I'm introducing cryptocats.me. So the way this system works, and we'll get into the source code in a moment, is, as you can see on the page, it's the automated cat photo tool. And to be honest, I was inspired to do this by evil corporations like Facebook, who says things like, oh, you just add one line of JavaScript to enable, this and that functionality of Facebook. Take this one line of JavaScript and put it on your web page anywhere, and the Facebook stuff will be enabled. Well, what they didn't actually tell people was that they were also using that to track the user data and create shadow profiles, at least allegedly. That's the only way that I can see that the shadow profiles that Zuckerberg was later grilled about, both by Congress and by the members of European Parliament. It's the only way that I can see the shadow profiles being made. But if it worked for Facebook, it should work for us. So the way this works is that, well, there's actually two ways it could work. One, you can just click the button, but if you want to embed it on your own page, you just copy these two lines here, the div and the script, and you paste it in your page. And it creates a call, and it allows you to have a cat photo. And, what happens in the background while the cat photo is being fetched? We're going to have a code walkthrough in a demo now. So first you can see the page, and here's another cat photo. And by the way, I have, it's from Kaggle.com. I found a cat photo database of some people they collected something like 6,000 cat photos because they were trying to do facial recognition on cats. And I thought, well, and it's public domain, free to use, and I thought, okay, this is great, I'll just use that. So thank you to the researchers at the Kaggle URL that created these cat photos for me. So, and this is called CryptoCats, and yes, I did get permission from Nadeem, the creator of CryptoCat, which I think is no longer being maintained, to use this. So the first thing we want to look at is just this general GitHub thing I'm using. To set this up, it's basically Python and Flask. So I set, for example, I have the key servers, and right now I just have a couple of key servers. I went through and tested to make sure that these would work with the code. But yeah, if one of these doesn't work, you can actually take this out and reload and rerun it. So the first step here is we want to create our key database. So I did some basic Python here. As you can see, we've got imported OS and Flask. So here is where we declare the gpgfs. This is where the key vault is, where the public and private keys. And then, excuse me, I'm thinking, well, what is a large, bloated, useless file that I can upload to the key servers and have lots of fun with it and ruin everyone's life? How about the blockchain? So I went ahead and downloaded a torrent of the blockchain, and this file right here, I think that's about 250 gigabytes in size. I think it was like a couple of years old, so there's probably a newer version of it. But yes, what we're doing is we're uploading the blockchain to the key servers. So now you can see here with Flask, and I open a SQL Alchemy database to a SQLite instance that I set up. And I have 3 fields, the ID, which is just a unique key that's in the database, fingerprint, this would be the GPG fingerprint of the key, and then it's whether it's uploaded or not. And this key, this database is sort of like the cat file, except it's in the database now, so it's easier access. So then we have the command here that creates the table, GPG key, with these fields in it, and then it goes through and creates a key. So at global GPG, it picks up where the GPG home directory would be, and so on, the key object. We give it some input data, and this is all just basically junk data, and I set it as a key length of 1024, but you can change it to whatever you want. I basically did that because I wanted something fast. And then the create key returns a key with that information, and is it the input data? Yeah, okay, so right. So then we have a command that goes through, and the other thing to point out here is, well, it's going through the counter, and I just put an insanely high number on it. The idea was it would just run until the file is over, and for context, I had this running on a little Hetzner system that's like, I don't know, 1 core, 2 gigs of RAM, something like that, and I ran it for about a week, and I generated around 100,000 keys. So that gives you an idea of the kind of stuff that this is going to generate. So then you have file seek. It seeks the 750. That was the number of characters that I could reliably fit into a comment. So it's taking the block file here, and it's as f, and then it's seeking through the block file from wherever the counter starting at 0, and count 0 times 750 characters, reads in those characters, and then it uses the create key to create a key where the comment itself, see the name comment here, where the comment in the key is the base64 decode, or the base64 encoding of whatever of the input from the zip file. Then it creates a database section. It adds the fingerprint of the key into the table, commits it, and then counter equals counter plus 1 moves on to the next one. Excuse me. So that's pretty straightforward. Well, then the guts of how the program actually works. So the previous was, this is just kind of a standalone. You run it once and you populate the keys. You can actually have this running in the background while you have the code, while you have the web server running too if you want. So then in what it's called app.py, which is also the default Flask, I have it once again. We have it pick in the GPG home, create a Flask app, just called app, and the SQL database. It goes to the database that we created before and specifies what the database is. Then we have a number of different functions here. So in order to really understand this, let's do a walkthrough of the code. So let's go back to the server. So we have src equals cat.js. Okay, well, what does this JavaScript actually do? And this, I'm taking advantage of some new stuff that I learned about. I haven't used JavaScript in a long time, and this fetch function and the fetch function and chaining the results is pretty cool. So first, we have URLs defined. I have the URL getNewKey and markUsedKey, and then here's the part where it creates the image that goes inside of the div for the cat, and then it sets the attribute to cat.jpg, and I'll show you what that is in a minute, and then set attribute class imgFluid, and I'm using Bootstrap 4 to make things to be somewhat fluid. So first off, we have the JavaScript. This automatically runs. It's great. Fetch URL. So it's going to fetch the getNewKey. Well, what does the getNewKey do? getNewKey. So we have the route getNewKey, and we have the global GPG. So it accesses the GPG store, and then it does a database query here. So what this is doing, it's fetching the first fingerprint. So it's getting all of the keys where there is no uploaded mark. So it's basically a binary flag. So that there is no flag on it, so the key hasn't been uploaded yet. And it just picks the first that comes. And this is a way that we can make sure that we're not uploading duplicate keys if that's something we actually care about. Key exporter, we then take the signature here, and then we we get the key signature from the database, and the key exporter is that actually exports the key itself. Excuse me. And then we want to, the format of GPG export armor is not something that you can just append to a post request. So here we have the URL lib where we actually just take like the carriage returns and end lines and change them into the characters that would be needed, and which I think is -od or something like that, I can't remember. Then we have the URL upload, which is going to fetch the key server. Now you saw the key server part before. Remember that file? So what this is doing, it gets all the lines from the key servers, opens and splits them up, and then it just picks one of the random key servers from the line and it returns that. So from that little list, we have this that picks a random key server, and then this returns some JSON. And it returns the JSON, which is the key. Key upload is the key itself that we want to upload. The key server is the URL we want to upload it to. And then we have the fingerprint, which is the key fingerprint. And then we return this in JSON format. So that goes back to the JavaScript. And we get so then return a response JSON, and then we have the function data, and now we take the data that we just established and we parse that into the key server, and fingerprint. So we have data.key, data.key server, and so on. And then we have to do a little bit of magic here. Okay, so it was moving 20 and OD here, right? So key body, we do a quick character replace where we, I'm trying to remember what that was doing. Oh, that's a space. Right. So what this is doing, it's some regex regular expression that replaces the instances of a -20 with plus, because this is how the HKP, the key servers, will handle it. Then we take the key body and prepend the key text variable in the post request, and then go through all the other URL encoded hex values and replace them where we need to. And then at the end, we append the pks-add, and then we do a post request, go into the key server with the content type and the key body we just created. And if it's a 200 response, then we can display a cat photo, and we return with the confirm URL. So let me just one side comment here, by the way, you may have noticed that a key server's files, the key server port is typically, I think it's 11371, and in this case it's HTTPS. There's a couple of reasons for doing it this way. First, the code that I wrote in 2015, that was in 2015. And since then, there's been a move to bring the whole web onto HTTPS. So now web browsers complain when you try to make a request from a site that has SSL enabled, especially with JavaScript, to a site that doesn't. So when I tried to use the JavaScript here, when I was trying to have a URL pointing to, or where was it, pointing to a key server without using HTTPS, it gave me problems. And because port 11371 is HTTP and not HTTPS, it wouldn't work. So some of the key servers have updated their code, these ones in particular, and I had to do some testing on this. So you can see it there, HTTPS, you can access it by that, and then you can also use port 443 to upload the key post request as well. And oh my god, that saved me. Because there was actually a point where I realized that this was a problem, and that I couldn't actually upload it with the JavaScript, and then I had to try it on a couple of these, and thankfully I was able to get it to work. Excuse me. So then we have document element by ID append child cat photo. I'll do that second. So first I want to show you this confirm URL plus key equals fingerprint. So what this does is you go into the, where is it? Confirm URL. Confirm URL goes to cryptocats.key/mark_used_key, which is here. So here with the mark_used_key, I have the argument that's a GET request with the parameter key. I assign that to be fingerprint. Then I do some checks on it. I do some regular expressions. So if it doesn't have hexadecimal characters and it's not 40 characters long, then you basically return the function out to a blank screen. And if it's then you check to see if it's in the database, and if it's not, then you return. And the reason for these two things, I know this is very ironic when I'm basically instructing people on how to DDoS the key servers, but this prevents me from getting DDoSed. It's kind of nice. And then at the end here, this prevents DDoSing, and it also comes into handy here because this is a database query. I couldn't figure out how to use the SQL alchemy to do update the table the way that I wanted, so I just have it set to update the GPG key, uploaded equals true, where the fingerprint is equal to the thing that we sent in. And the first rule of SQL queries is that you never allow you always parse the input, and you always you never allow unsanitized input into the database. Excuse me. And then this here runs, and then it updates the database and lets it know. And now one of my favorite parts of all of this, you can see here we have document.getElement by ID is cat, and it's just a cat photo, right? Well, what does this actually do? In this part, the route for the cat, we have the photo as random choice, we have the we have this directory here of the cat folder. Like I said, it has about 6,000, maybe 8,000, I can't remember how many cat photos in it, of varying sizes. None are more than like a megabyte though, and this is one of the really nice things about the way the modern web is completely filled with bloat, wherein you can have megabytes of JavaScript coming down and people don't even bat an eye because they're all using broadband. And so actually I'm not sure how big Bootstrap is, which I'm including the CSS for that. I don't think it's that big, but in general the biggest the biggest request that this code is going to generate is a cat photo, and everyone likes cat photos, so there you go. So this does the list directory and it picks a random photo, and then it carves it into a response. So the folder name plus the cat photo, and then the MIME type is image JPEG. And then this is something I ran into that was kind of important. I have to set the cache control header to no store. What this does is it makes it so that the web browser does not cache the cat photo, which means that every time you hit refresh on the page, you get a new cat photo, which is what everyone wants. So I'll just do a quick demo. I mean, I kind of already did, but I click this button and it runs the JavaScript, and we have a cat photo. Let's see. So that's basically what I got. The code is available for free use. Well, first off, it's available at cryptocats.me if you want to test it out and run it yourself and just get some cat photos. And if you want to set up your own CryptoCats server, you can go to this GitHub URL and you can set it up, and it's really not so hard. The way that I set it was with an Nginx reverse proxy, which then went to the Flask URL. I had it wrapped in GUnicorn, which allows multiple workers to be running instead of the base Flask. But in general, it's pretty nice. If you have any questions about this, feel free to email me or ask any questions after the talk. And by the way, yes, those GPG key IDs are real. They all work. I very much implore, if you want to send me an encrypted message, use the first one. I don't actually know if I have the other private keys anymore. Thank you very much, and I'm now open for questions.
So aesthetics, we have some questions from the audience. The first question would be, it's not clear that abusing key servers really break the PGP web of trust. Please elaborate.
That's a good question, and what I would say to that is, I don't think that the key servers should exist. I do not think that the web of trust works. I think that the web of trust, when you have people upload, and especially their trust relationships to it, jeopardizes their privacy in ways that a lot of people are not aware of. And therefore, I think it's actually the existence of the key servers is a problem. So abusing them, I've tried rationally, as you saw in the first few examples, I've tried rationally explaining why you shouldn't use it, and people didn't listen. And I said, well, maybe I can just take care of it myself.
Fair enough. There's another question. Since the key servers network is so vulnerable to DOS attacks, does this mean we should really stop promoting this as a critical infrastructure?
Yes. The key servers don't work. Here's what I mean. Putting up keys, this is complex. Let me try to break it down to something very small. When I upload a key, the whole point of the key servers is to know that the key belongs to me. And that's what the whole point of the trust relationships is. But first off, you can fake that. If you actually look, if you do the data mining and you see the different clusters, you can spoof that. And ultimately, there's no way to tell. If the question is, how do I share my key? There's a simple answer to that. Put your key up on your website or somewhere else. Or you can say, yeah, the key is in the key server, and then you go to my website or your Twitter account or whatever. Here's my signature, and you can get it that way. You can put the keys up anywhere you want. The issue is the trust relationships. And if you think about what happens when, well, one example I've used before to describe this is, let's say that I'm at a key signing party and I sign somebody's key. And a couple years later, that person is indicted for a crime. And the government is doing discovery to try to find everyone who's related to that person. And I get a phone call or worse because I am linked to them by the key signing. I'm not aware of a case where that's happened yet, but that's a possibility. So does that answer that question? Like, there are alternate ways to do this. Would my confidence be...
There's another question.
So, oh, yeah. Go on.
Would your confidence be increased if we could remove keys from key servers? Is there even a reasonable solution to allow key removal?
So this is something I thought about a lot, and I don't know that there's a way to do it unless we introduce state into the key servers, and that's really hard, and it actually changes the entire nature of how the key servers work. For example, the issue with the web of trust is I upload a key to a key server, and it will ideally immediately, but there's some delay. It gets propagated to all the other key servers. Well, if I delete the key, due to the nature of the key servers, it's just going to synchronize with another system, and the key's going to go right back to it. So the only real way to do that would be to have the keys removed from all the key servers at once. And as you saw earlier, the key servers are not all running the same software. So to expect them to be doing key management like that is like, I think that's too much of an ask.
All right. Depending on the time, we can take some more questions, but I have one more which I can ask you right now from the audience. How do you feel about key-based approach?
The issue with Keybase is that it's not public. At least the last I checked, they don't do nightly dumps of their keys or anything like that. Further, I think it is a, how to put it, I hate to use this kind of language, but they're like trying to polish a turd. And it's basically putting a social network onto something that already doesn't work. It's very pretty, it's very easy to use, and I think people are using it as a social network. And if you want to use a social network, great. But in terms of a web of trust, well, first off, I'm not going to trust anything unless I can see it. And if Keybase, maybe they do this now. The last time I checked, they were not doing nightly dumps of all their keys, whereas SKS, which I've been using, does. And beyond that, again, this may be outdated, but when I tried to use Keybase and I used their tool to create a key, but the default option was to have my private key stored on their server, which defeats the entire point of using GPG encryption. So I'm mixed. I don't want to tell anybody not to do this and that. And maybe Keybase has some magic behind the scenes I don't know about, but based on what I've seen, it's the same crap.
All right, we have one last question. Why hasn't doxers or kiddie porn or whatever appeared on key servers, since it's so easy to upload arbitrary data?
Okay, this is a question that's come up before, and the real answer is that we don't know. The question being, why hasn't it happened? We don't actually know if it's happened or not, because I released the GPGF or pgpfs a couple of years ago, and I didn't keep track of who's using it. I guess I could download the SKS dump and take a look, but then I would have to go through and reconstruct anything that's been uploaded to it. And I guess the question would be, what's the benefit of doing that? And in terms of doxing, one of the questions that you have to ask is, if we've already established that we can't really trust anything on the key servers, if we could trust it, then we wouldn't need the web of trust. Then why would I trust what's being doxed on there? I could just upload something and say that, some hacker's real name is Bill Clinton. And I mean, that's just nonsense. So it's hard to say.
All right, one last question, aestetix. What are your thoughts on AutoCrypt as an alternative to WOT?
I don't have any because I'm not super familiar with AutoCrypt. So I will have to look into that. Thank you for letting me know.
Well, we still have a couple of minutes, so a very short answer to this last question. What do you recommend we use instead of key servers network? Manual sharing of keys in person, or something else that you would recommend?
Sure. Well, first off, sharing keys in person is always... so I've got another side rant on this. Key server parties that require a government-issued ID are bullshit. If you actually look at the specifications, I think it's RFC 4880 of the OpenGPG format, where it says what the trust levels are. It's very, very vague on that. I've actually talked to a couple of the designers, including John Callis, about this. And the whole point of it is that there are different avenues where you can institute trust. So maybe I do trust a government ID. I personally wouldn't. Maybe I do trust somebody who's been introduced by somebody else. The whole point of the trust levels is supposed to be you have alternate avenues that you can use, and therefore in-person key sign-ins with ID goes against that entire philosophy. There was another, so in terms of sharing keys, so I realize that making a website is hard to do now that Facebook is there, but I don't know, if you have we have verified Twitter accounts, so why don't you put your key on that? I mean, there you are. And by the way, that has the same problem, but that's beyond the scope of this talk.
All right. Thank you so much, aestetix, for your valuable time and being part of Hope 2020. For our audience, stay tuned. We will be back with another cool talk in 10 minutes. Until then, stay safe. Thank you so much again. Bye.
Absolutely. My pleasure.